We used to think that Saturn was too far from the sun and too cold to play host to anything dramatic. We couldn't have been more wrong. The planet boils and bangs with active weather, storms, lightning, and auroras. The rings constantly evolve. And the moons aren't the frozen snowballs we expected. They're shaped by active geology, with warm water geysers and lakes of liquid methane. And now, on Saturn's largest moon, Titan, scientists may have uncovered the first tangible evidence of extraterrestrial life.
Our search for life has been focused on liquid water. Follow the water. I think it's a good strategy. But I think we are limiting ourselves if we think that that's the only place to look. I think liquids may be interesting even if they're not water.
Astrobiologist Chris McKay believes that life on Titan may have evolved to live in liquid methane, not liquid water. But Titan's so cold, simple life would play by a different set of rules, where bigger is better.
When we go to other worlds, we're going to be looking for bacteria, and we assume that they're going to be very small. But you could ask the question, why are bacteria so small? Well, I think the answer is because they live in water.
On Earth, bacteria don't need to grow big to thrive. Water dissolves almost everything, so it provides a nutrient-rich environment where small and simple brings success.
We go to Titan, where the liquid is liquid methane, liquid ethane, very different from water. There's no reason an organism should be small. In fact, quite the opposite, it should be huge.
McKay envisions enormous single-celled organisms looking like sheets of paper. Their huge surface area would maximize the uptake of food from the nutrient-poor liquid methane.
I predict that there's life on Titan living in liquid methane. You won't need a microscope to see it. You'll need a yardstick.
When Cassini released the Huygens probe high above the cloud tops of Titan, McKay realized he had an opportunity to bolster his theories of life on the surface. His methane-loving life forms must be eating to survive. Perhaps Huygens' delicate sensors would pick up evidence of ground-level feasting.
As Huygens was on its way to Titan, I'm sitting in a hotel room writing up a paper saying, hey, what if there's life on Titan? What would it eat? And how would we detect it? How would this probe flying through the atmosphere detect it? Literally the day Huygens landed, I submitted this paper to the journal, predicting that if there was life on Titan, it would eat hydrogen, and the probe would be able to measure this depletion in hydrogen. So let's look for hydrogen.
Huygens parachutes through Titan's atmosphere, sampling the gases as it goes. The upper atmosphere has plenty of hydrogen, so do the middle layers. But at the ground level, there's a surprise result: an apparent drop-off in the concentration of hydrogen in the air. Something, or perhaps someone, was using it up.
When I heard a report that there was a depletion of hydrogen, my heart raced, because I thought, if this is hard data for depletion of hydrogen, I can't imagine any other way besides biology to explain that. It's exciting in that it's consistent with what we predicted, but we have to wait for this to be confirmed by other calculations, by direct measurements, and so on.
If future missions can confirm methane-based life on Titan, it will surely be the greatest discovery in the history of science, because this low-temperature biology must have arisen independently of life on Earth.
If we discover life, let's say, on Mars, there will always be the possibility that rocks and ice and bits of material could have been exchanged. But the chances of that happening from Earth all the way to Saturn are next to nothing.
If we find a second example of life in our solar system, especially in a place like Titan, which is so alien to the Earth, so cold and so different, that tells us something excruciatingly important, and that is that life must be everywhere in the universe.
Robotic missions offer tantalizing hints of simple life on Enceladus and Titan. But is Saturn's realm only fit for giant bacteria? Or is it a place we humans could one day call home? Saturn orbits 1 billion miles from the Sun, so far out that it takes an hour for its reflective light to reach our eyes. Yet the future of our civilization may rest on humans one day colonizing the moons surrounding this gas giant planet. It won't be easy, but Saturn has something worth the trouble. A magical source of fuel called helium-3 that could satisfy our increasing hunger for energy for millions of years.
Some futurists believe that we have to have a commercial incentive to going to Saturn, not just to mine the minerals of the moons of Saturn, but also to harvest fuel in the form of helium-3. Helium-3 is a rare substance that we could use in fusion engines to provide perhaps unlimited energy.
Helium-3 is uniquely suited to a form of energy production called fusion. The same process that burns in the heart of a star. When two nuclei are crushed together under enormous pressure, they fuse, creating a new, heavier atom and a burst of pure energy. Best of all, helium-3 doesn't release any of the harmful radiation associated with other fusion fuels. The only trouble with helium-3 is that there's precious little to be found on Earth.
Now, you can find some helium-3 on the moon, but the major supplies of helium-3 in our solar system are located in the atmospheres of the giant planets. I call the gas giants the Persian Gulf of the solar system because they are the location of its primary energy resources outside of the sun.
The gas giants provide a near inexhaustible supply of helium-3, but how could we extract it? Jupiter has the most, but the planet's immense gravity and dangerous radiation belts make it a no-go for mining. Neptune and Uranus are way too far away to be practical. That leaves Saturn, with relatively low gravity for such a big planet and far lower levels of deadly radiation than around Jupiter.
If we're going to have a future human economy based on using controlled fusion and helium-3, Saturn is the destination of choice.
Futurists envision winged drones flying through the upper atmosphere of Saturn, scooping up gases. But where to process this super fuel? The ideal base of operations would clearly be Titan. With gravity as gentle as our moons and a thick, Earth-like atmosphere, Titan is surprisingly suitable for a human outpost.
We could have huge dome settlements on Titan. They would not have to be strong enough to hold pressure. They could just be thin, inflatable membranes. You could have dome cities like you see in science fiction, which are really not possible in places like the moon.
Walking out onto the surface of Titan would be much easier than on the moon or on Mars.
The pressure on Titan is kind of nice. It's 1.5 times Earth pressure. You would need a source of oxygen, and you need a very warm coat. But it wouldn't feel as cold as you might think because the atmosphere is calm and there's not strong wind. I think a coat like you might wear in Antarctica might be adequate. So you can imagine somebody stepping out of a spaceship, having a parka on, a mask like a scuba mask to provide oxygen, and literally walking out on the surface.
Titan's low gravity and dense atmosphere could even send us soaring from place to place.
Let's say you had, it's a little bit of a wing on your arm, and you started to flap your arms. Remember, it's almost like you're on the moon, but with a thick atmosphere, and you'd really be able to lift yourself off the surface, maybe fly just a little bit.
When the helium-3 trade route has opened and the Earth becomes a fusion economy, a new generation of rockets will open up interplanetary travel to everyone, taking humans to Mars and Jupiter in months, not years. And helium-3 might even power adventure tourism to Saturn itself.
You can imagine in 100 years when space travel is easy and there will be hotels orbiting the moon and Mars and everything. What would be the one? What would be the place, right, to go? It would be Saturn.
I would hope one day that there is such a thing as space tourism and people can visit places like Enceladus. This should be called the Enceladus Interplanetary Geyser Park because it would be a phenomenal place to just go visit.
Standing on Enceladus would be an amazing sight. All of this frost condensing back out on the surface makes it incredibly brilliant white. It's got some of the best powder snow for skiing anywhere in the solar system.
You could get close enough to actually see the individual rings. Maybe even see the little moons in the gaps, sculpting and pulling and pushing and prodding, shepherding those ring particles around. You could go back over and over again, and it would always be alien and exotic and exciting.
From a cold, dead jewel in our telescopes to a place alive with magic and mayhem, Saturn and its worlds have come alive and may harbor life itself. Someday soon, this planet could remake our universe, and nothing will ever be the same.